Niranjan, start பண்ணிடலாம். Okay. Good morning to all. Ozone is important for life. Ozone blocks the harmful UV rays from the sun to protect the biological process on the earth, which are essential for sustainable life. I welcome Dr. V. Suresh Kumar, HOD SNH, to give a welcome address.
Good morning, all of you. On behalf of the management of King's College of Engineering, our beloved Secretary Sir, Principal Madam, Vice Principal Sir, and all HODs and faculty members, I welcome our today's resource person, Dr.M. Rukmangathan, to deliver a wonderful talk about the ozone for life. I'm sure that this webinar will enlighten all the participants about the importance of the ozone for our life. Once again, I welcome all of you and all the participants of King's College of Engineering and other colleges. Thank you.
Chief guest introduction, myself, Dr. S. Udayakumar. I am very happy to introduce the resource person today's webinar. Our resource person, he qualified CSIR NETS lectureship and examination during the final year study of master degree. He completed his doctoral degree in Bharatiyar University, Coimbatore, during the year 2015, and his PhD reports were received highly commended. Status from all the three examiners is specialization in physical organic chemistry. He is working in Arasu Engineering College since 2001. He is having 22 years of teaching experience in engineering colleges and 11 years of research experience. He headed chemistry department for more than 20 years. He served as program officer for various tubes such as NSS, OYAC, and Arasu. From the inception of our institution, he is coordinating university examinations and other activities. He has published 25 research papers in reputed journals, presented 20 research papers in national and international conferences, and won the Best Papers Award for about 7 times. He attended more than 50 seminars, faculty development programs, workshops, etc. He is being a peer reviewer for some reputed journals, as editorial board member for about 3 journals. He is very active in research by publishing papers in journal, presenting papers in conferences, receiving financial assistance from the various funding agencies like CSIR, UGC, DST, AICTE. So we are all very happy this morning to have you, sir. Thank you for your opportunity. Thank you. I welcome you, sir.
Good morning to all. Please, any one of you confirm me. Are you receiving my voice very clearly?
Yes, yes. Yes, sir.
Yes. Oh.
I hope that all of you seeing my screen. Okay. First of all, I wish to express my heartiest thanks to the management, principal, vice principal of King's College of Engineering, Kunalkulam. Also, I am very much thankful to Dr. V. Suresh Kumar, HOD, Department of Science and Humanities, Dr. P. Saravanan, Dr. S. Udayakumar, and staff members of Chemistry Department, and participants, and also my dear students, friends of King's College of Engineering, for offering me this wonderful chance to discuss with you. Well, all of us know that 16th September of every year is being celebrated as World Ozone Day. That means International Day for the Preservation of the Ozone Layer. On account of this World Ozone Day, King's College of Engineering, Punalkulam is organizing this beautiful webinar, and I hope that this webinar will definitely inculcate certain important outcomes to the participants' mind. What are all the focus points of this webinar? On which points I am going to emphasize during this webinar? Ozone, whether it is good or bad. Then formation of ozone, how ozone is formed in the atmosphere. There is one separate mechanism for it that is called the Chapman Mechanism that we are going to discuss. Then the ozone layer formation, why ozone layer is needed, importance of the ozone layer. Then depletion of ozone layer, that means ozone hole development in the stratosphere. Then ozone hole development in Antarctica region, that requires a separate explanation. That part we are going to see. Then mechanism of ozone layer depletion, followed by effects of ozone layer depletion. And finally, we are going to see some remedial measures to minimize the depletion of ozone layer and Montreal Protocol. All these things we are going to see in this webinar. We know very well that ozone is a highly reactive gas composed of 3 oxygen atoms. It is both a natural and man-made product. Of course, ozone is formed by natural means, or it may be formed by the human being activities. Actually, ozone is present in the Earth's upper atmosphere. Actually, we know very well that atmosphere is having 5 layers. The layer which is closer to the Earth's surface is called a troposphere. The second layer is called a stratosphere. Ozone may be present in the troposphere as well as in the stratosphere. Depending upon the place whereby the ozone is occurring, then ozone influences our life either in good or bad ways. When ozone is present in the troposphere, it is called bad ozone and influences our life in bad manner. When ozone is present in the stratosphere, the second layer from the Earth's surface, it is called a good ozone. It is doing some positive ways. It is protecting our life. Now let us see what is called a good ozone and the bad ozone one by one. Ozone that is found in the troposphere, the layer nearer to the ground surface, is called the bad ozone. This is the layer. When ozone is present in the troposphere, it is called bad ozone. How bad ozone is formed in the troposphere? It is formed when sunlight alters various chemicals emitted by the human beings, especially due to the photochemical smog reactions between volatile organic compounds and nitrogen oxides. For that reactions to occur, definitely it needs heat and sunlight. Okay, in troposphere, bad ozone is formed. Now let us see how the bad ozone is influencing our life in negative way. Breathing the bad ozone or inhaling the ozone may cause chest pain, coughing, throat irritation, then congestion problem and bronchitis, lungs-related diseases, and emphysema and asthma. What is called emphysema? Emphysema means the production of scar in the lung tissues, just like this. This is called the emphysema stage. The production of scars in the lung tissues, not only that one, inflammation of the inner walls of the lung tubes, that is called emphysema. Here we can see the diameter of the hole is very, very minute. That means the inner wall of the lung tissues may get inflamed, and hence we are unable to breathe the oxygen. That is the bad effect of ozone, emphysema. So reduces the lung function and the inflammation of the lining of the lungs. Repeated exposure to the ozone may permanently cause the scar in lung tissues. So all are related to respiratory problems. In plants, what is the effect of ozone? Damage to vegetation and reduces the crop yield in general. The micropores that are present in the plant leaves may get opened and hence the leaves get damaged. Once the leaves get damaged, it means the plant yield and the crop yield may get decreased further. And this is the bad effect of ozone in the plants, especially this one. The microporous structure present in the leaves get opened and hence the leaves gets damaged. Now let us see the good ozone. Good ozone means it is found in the stratosphere, the layer next to the troposphere, this one, the second layer. Here the good ozone is found. This layer is called the stratosphere, which is present above the troposphere. Stratospheric ozone normally forms in the stratosphere, and its concentration is about 2 ppm to 8 ppm, and hence it forms the layer that is called the ozone layer. You know, the important function of ozone layer we know very well. It helps us by protecting the ultraviolet radiation coming out from the sun. If the ultraviolet radiation is reaching the Earth's surface directly without any filtration, it may cause sunburn and skin cancer. Let us see the bad effects of ozone. Let us see the bad effects of ultraviolet radiation in the forthcoming pages. Now, let us see how the good ozone is formed in the stratosphere. As I already told, there is one mechanism called the Chapman mechanism. Good ozone is continuously produced in the atmosphere, that means in stratosphere, and destroyed automatically through the photochemical reactions. The Chapman mechanism involves the molecular oxygen, O2, atomic oxygen, O, sunlight, H nu, and the ozone, O3. Let us see this animation picture. Here, ozone exists in the upper atmosphere as the consequences of photochemical reactions between molecular oxygen and atomic oxygen in the presence of sunlight. So molecular oxygen combined with atomic oxygen to form ozone. That is the first step in the Chapman mechanism. We already told that the ozone is continuously produced and destroyed in the stratosphere automatically. In the previous slide, how the ozone is formed in the atmosphere, we have seen. In this slide, how it gets destructed. Ozone is destroyed naturally by reactions with ultraviolet radiation. Here you can see. On reaction with ultraviolet radiation, ozone gets destructed to form molecular oxygen and atomic oxygen once again. Due to this property only, ozone layer is able to filter the ultraviolet radiation. Another destruction, ozone is also getting destroyed naturally by reactions promoted by collisions. Here ozone collide with the atomic oxygen to produce molecular oxygen. In this way, this is called a self-destruction. The third one, as well as being destroyed by collisions with itself, 2 or more ozone molecules may get collided to produce molecular oxygen. So in this way, ozone is produced naturally in the stratosphere and gets destroyed, and once again produced naturally. This is the simple one. Ozone is being formed naturally, ozone being destroyed naturally, once again it is forming naturally. So this cycle is going on repeatedly. So stratospheric ozone is considered as the good ozone because it has the property of absorbing harmful UV radiation. We have already seen here. So ozone that is present in the stratosphere is considered as the good ozone because it can react with the harmful UV radiation and gets destructed into molecular oxygen and atomic oxygen, and thereby protecting the human beings, plants, and animals present on the Earth's surface from the damaging UV radiation. Now let us see how the ozone layer is formed. The ozone layer is the common term for the accumulation of high concentrated ozone in the stratosphere. Actually, the stratosphere is spread over from 12 kilometers to 50 kilometers above the Earth's surface. Within 20 to 50 kilometers, actually, the concentration of ozone is somewhat high to about 2 ppm to 8 ppm. That is called ozone layer. This ozone layer is covering the entire planet and protects the life present on the Earth's surface. Importance of the ozone layer. This we know very well. If there is no ozone layer, no life can survive in the Earth's surface. So without the ozone layer, life on the Earth's surface would not be possible. It protects us from the damaging UV radiation of the sun. In particular, it filters UVB radiation. What is called the UVB radiation? Here, the initial B stands for ultraviolet B-type radiation. That means already there are UVA radiation and UVC radiation. This is the order: UVA radiation, UVB radiation, and UVC radiation. UVA radiation is having longer wavelength, UVB radiation is having middle order wavelength, and UVC radiation is having shorter wavelength. The ozone layer especially filters the UVB radiation. Of course, it is able to filter UVB as well as UVC radiation. In particular, it filters UVB radiation because it is very, very dangerous. It may cause the skin cancer if it reaches the Earth's surface directly. UVB rays are the part of sunlight that gives one sunburn. Look at this picture. This one is the Earth's surface. This one is the first layer nearer to the Earth's surface, troposphere. Here, the surface level ozone that is formed due to the photochemical smog may be present in the troposphere. We call it as bad ozone. Of course, from the industrial chemical reactions and all other things, photochemical smog may occur. During the photochemical smog, bad ozone is formed, you know very well. The layer that is next to the troposphere, that is called stratosphere, here only the ozone layer is formed. I already told that ozone layer is able to filter the ultraviolet radiation that is emitted from the sun. We have already mentioned 3 types of radiation: UV radiation, UVA radiation, UVB radiation, and UVC radiation. From this picture, we can clearly understand that the ozone layer is able to filter, it is able to block almost 100% of UVC radiation. It is able to block 95% of UVB radiation. It is not filtering UVA radiation at all. That's why during the summer season, we are getting sunburn and the hot condition we may feel. That is mainly due to UVA radiation, because the ozone layer is not filtering the longer wavelength radiation, UVA radiation. But this one is most important. Filtering of UVB radiation by the ozone layer is the welcoming step. If it reaches the Earth's surface directly, here only 5% is reaching. If 100% of the UVB radiation is reaching the Earth's surface directly, what will happen? The people may be suffered by various diseases that we are going to see in the upcoming pages. This is another picture how the ozone layer is filtering the UVB radiation. UVC radiation is 100% absorbed by the ozone layer. UVB radiation is 95% absorbed by the ozone layer. And the UVA radiation is absorbed only for the extent of 5%. The remaining 95% may reach the Earth's surface. As the sunlight passes through the atmosphere, all the UVC radiation and most UVB radiation is absorbed by the ozone layer. Not only by the ozone layer, but also by the water vapor, oxygen, and the carbon dioxide. But UVA radiation is not filtered as significantly by the atmosphere. Unprotected exposure to UVB radiation may damage genetic skills, DNA in skin cells, genetic defects or mutations, etc. Finally, it leads to melanoma skin cancer. These rays can also cause the eye damages like cataracts and the eyelid cancers, etc. Now let us see slowly how the ozone layer is getting thinned. What is called ozone layer depletion. What are the substances that are responsible for causing the ozone layer depletion? We are going to see. The ozone hole has been developed in the atmosphere because we, the human beings, have already polluted the atmosphere with so many chemicals containing chlorine and bromine atoms. What are called ozone depleting substances? The ozone depleting substances essentially consists of chlorine or bromine atoms, which are extremely reactive while they are in the free stable state. The following gases are accumulated in the atmosphere and are found to be instruments in the ozone layer depletion. The main one is, the main chemical which is causing the ozone layer depletion is a CFC, chlorofluorocarbons. These CFCs are used in refrigerators, propellant in aerosol spray cans, blowing agents, foam blasting, blowing agents, etc. So chlorofluorocarbons play a major vital role in causing the ozone layer depletion. The second one is hydrochlorofluorocarbons. Here also the sources from which the HCFCs are emitted, refrigerants and flowing agents. Bromofluorocarbons, we are frequently using fire extinguishers in research laboratories and in home theaters, etc. So fire extinguisher is the major source of emitting the bromofluorocarbons. These fluorocarbons are also responsible for causing the ozone layer depletion. What are the other chemicals? Certain halogen compounds, especially halogens, halogenated hydrocarbons, halogens. They are the potential ozone destroyers up to 10 times more powerful than the CFCs. So halogens, halogenated hydrocarbons, are very, very dangerous. They are 10 times more powerful than the CFCs. Sometimes the atmospheric sulfur dioxide is converted into sulfuric acid, which greatly increases the rate of ozone depletion. All the above mentioned chemicals, CFCs, HCFCs, BFCs, and halogens, are so inert. They can persist in the stratospheric atmosphere for a longer time. That's why the presence of ozone depleting substances such as CFCs and HCFCs, they are continued to deplete the ozone layer for about 50 more years. Of course, the ozone depleting substances that are emitted, that are released in the stratosphere before 50 years, even still now, they are causing the depletion of ozone layer because they are able to persist in the atmosphere for the prolonged time. This one is called ozone hole developments. How the ozone hole is developed. Now let us see the ozone hole development in Antarctica region. Why we have to see the ozone hole development in specifically in Antarctica region? Just a minute, please. The Antarctic ozone hole is a thinning or depletion of ozone in the stratosphere over the Antarctic each spring. The development of ozone hole over the stratospheric atmosphere of the Antarctic region is the annual phenomenon. During each spring season in the Antarctic area, the ozone hole development may occur. Why specifically ozone hole is developed over the Antarctic region? Not only in the Antarctic region, we are going to see the Antarctic region. However, the same phenomenon may happen in North Polar region, Arctic region also. So in polar region, the development of the ozone hole is more frequent. It is the annual phenomenon. Why? This damage occurs due to the presence of chlorine or bromine atoms from ozone depleting substances in the stratospheric atmosphere, and the meteorological conditions that are existing in the Arctic and Antarctic region is favoring the ozone hole development. Please remember that ozone hole development involves certain mechanism. It is actually getting started from the free chlorine or free bromine atoms reacting with the ozone. For these reactions to occur, some specific meteorological conditions are required in the stratosphere. Over the Antarctic region, the stratospheric clouds are present. These clouds are providing the ice crystals atmosphere. Over this ice crystal atmosphere, the ozone layer depletion mechanism reactions are happening very easily. That's why during each spring season of Antarctic region, ozone hole is developed frequently, and this is considered as the annual phenomenon. The fact that most of the ozone depletion happens over the Antarctica region also requires some explanation, special explanation. Let us see that special explanation. CFCs and other ozone depleting gases may come from anywhere, but it is in the south polar stratosphere where the conditions become most favorable one. The condition I have mentioned now, the stratospheric clouds may provide the ice crystal situation. Over the ice crystal situation, the ozone depleting reactions may happen easily. The key factor is the presence of stratospheric clouds and the lack of atmospheric mixing. In the South Polar region, in the higher altitudes of South Polar region, there is no atmospheric air mixing in proper manner during the winter and the early spring season. Due to the lacking of atmospheric air mixing and also the presence of stratospheric clouds to provide the ice crystal atmosphere, the ozone depleting reactions are happening very easily, and the ozone hole is developed more frequently in the Antarctic region. So we have specified the reasons for the ozone hole development in the Antarctica region, especially the presence of stratospheric clouds and the special meteorological conditions, and providing the ice crystal situation for the reactions to happen easily. Not only these reasons, there is one more reason for the ozone hole development in the Antarctic region. That reason is called Erebus volcano. This one is Erebus volcano that is frequently happening. These volcanic eruptions are frequently happening in the Antarctica region. The extremely high Erebus volcano gas emissions during the volcanic eruptions, the volcano gas is emitted over the stratospheric clouds. That volcanic gas emissions contain HCl and SO2 gases. Actually, it happened in the early 1980s. That stimulated the ozone depletion and the ozone hole formation in the Antarctica region. So at least before 40 years, actually, the ozone hole was developed in the Antarctic region, and it was found that the ozone hole present over the Antarctic region has been closed during the January 6th of 2021. And let us see later that part. So also resulted in the subsequent total ozone decrease due to the accumulation of volcanic gases. So over the Antarctic region, the ozone hole development was mainly due to some reasons. Presence of the stratospheric clouds, providing the ice crystal atmosphere on which the reactions may happen very easily, and due to the lacking of atmospheric air mixing during the winter and the early spring season, and another Erebus volcano presence. Now let us clearly see the mechanism of ozone layer depletion. Actually, the mechanism by which the ozone layer depletion happens is somewhat complex. How the chlorofluorocarbons react with the ozone, that mechanism is somewhat complex, but it requires certain weather conditions to exist. Let us see the mechanism now. Once chlorofluorocarbons are emitted from the refrigerant units or air conditioning units, or from aerosol sprays, or from blowing agents, or BFCs when they are emitted in the atmosphere from the fire extinguisher, etc., they will reach the stratosphere. Just a minute. They will reach the stratosphere. Now the unreactive CFCs can be broken down by the ultraviolet radiations to release reactive chlorine. Let us see this one. For ozone layer depletion reactions to occur, free chlorine atom is needed initially. That chlorine atom is actually coming from chlorofluorocarbons that are released in the stratosphere by human being activities. So chlorofluorocarbons that is released in the stratosphere getting broken down by the ultraviolet radiation that is falling on the CFCs to produce free chlorine atoms. Okay, actually this free chlorine atom is the initiator to start with the ozone layer depletion. For the breaking of chlorofluorocarbons to form the initiator of chlorine atom, free chlorine atom, this reaction, first step, CFCs, chlorofluorocarbons, undergoes breaking by the presence of sunlight or ultraviolet light to release the free chlorine atoms. For these reactions to occur, some specific conditions are needed. Atmospheric clouds, stratospheric clouds must be present, and they should provide the ice crystal surfaces on which the chemical reactions can take place. That's why these conditions are entirely satisfied in Arctic and Antarctic region. That's why the ozone hole development is very more often in these regions. Now coming into the picture, once the chlorine atom is formed, it reacts with the ozone layer and form ClO. and molecular oxygen is getting released. That means ozone is getting decomposed in this reaction. Now the ClO, once it is formed, it further reacts with the ozone to produce chlorine atom, free chlorine atoms again, and the molecular oxygens are released, The free chlorine atom that is formed in the second step will enter into the first step once again and start to deplete the ozone layer again and again. So simply it involves two mechanisms. In first two steps, in the first step, the free chlorine atom reacts with the ozone to produce a ClO. Ozone is getting destructed. In the second step, the ClO further reacts with the ozone to regenerate the free chlorine atoms again and again. This free chlorine atom will repeat the cyclic reactions continuously. So one chlorine atom can destroy 1 lakh molecules of ozone before it leaves in the stratosphere. That is the dangerous one. Since the mechanism involved in the cyclic mechanism, one chlorine atom is able to break down, it is able to decompose 1 lakh molecules of ozone. That's why the issue of ozone layer depletion is considered as the major issue globally. And this is another way in order to understand the mechanism very simply. As I mentioned, in the first step, chlorofluorocarbons undergoes the breaking process to release the free chlorine atom. The free chlorine atom reacts with the ozone to produce a ClO. Of course, ozone is destructed into molecular oxygen on another side. Two ClO molecules combine together to produce chlorine peroxide this way. Now, sunlight will break down this chlorine peroxide to produce free chlorine atoms and oxygen again. These free chlorine atoms once again will continue to react with the ozone to start with the cycle again and again. In this way, ozone layer depletion occurs. Now let us see the effects of ozone layer depletion. Simply speaking, the depletion of ozone layer will permit the damaging ultraviolet radiation to reach the Earth's surface directly. So this ultraviolet B radiation, what will do on the plants, animals, and the human beings? Of course, the depletion of ozone layer may produce harmful effects on human beings and the phytoplankton's growth in the marine ecosystem, and also it suffers the agricultural activities also. On human beings, ozone layer depletion increases the amount of ultraviolet radiation that reaches the Earth's surface. Actually, previously we have seen that the ozone layer is able to block, it is able to filter about 95% of the UVB radiation. If the ozone layer is depleted, that means the amount of UVB radiation that reaches the Earth's surface will increase from 5% to some other things. From the laboratory and the epidemiological studies, UVB radiation can cause non-melanoma skin cancer, what is called non-melanoma skin cancer. We, the human beings, are having certain melanin content on our skin cells. If UVB radiation will reach the Earth's surface means we are exposed to UV radiation. Our skin is exposed to UVB radiation. Now, the melanin content that is present in our skin cells may get decreased, and it causes a non-melanoma condition and finally leads to skin cancer. That means malignant melanoma development is formed. That means skin cancer is developed. Not only for the human beings, even fish may also be getting suffered by non-melanoma skin cancer. This one. In addition to skin cancer, UVB radiation may lead to the development of some eye diseases like clouding of eyelids, that is called cataracts, and even the cancer in the eyelid may be formed. So 10% of depletion in ozone layer may result in 30% increase in the chance of skin cancer infection. So ozone layer depletion is the major issue because it makes almost all the people into skin cancer disease. This one is cataract formation. This one is called non-melanoma skin cancer. Continuous exposure to UV radiation, especially UVB radiation, may lead to the formation of certain pigments on our skin cells. This is due to the insufficient amount of melanin present in our skin cells, and hence this non-melanoma condition may lead to skin cancer. What are all the bad effects of reaching the UVB radiations on plants? UVB radiation affects the physiological and developmental processes of plants. Once the developmental process and the physiological growth is suffered, means it leads to decreased crop yield. Plant kingdom will be diminished, will be vanished certainly. So indirect changes that is caused by UVB radiation can have important complications such as plant competitive balance, herbivory, plant growth, plant diseases may happen. Of course, it will suffer the biogeochemical cycles that is occurring in the plant kingdom. On marine ecosystem, how far the ozone layer depletion affects the marine life? We all know that in marine ecosystem, phytoplanktons are the main producers. They are forming the base of the food chain and the food web that is operated in the marine ecosystem. But these phytoplanktons are under severe pressure due to the UVB radiation. UVB radiation may produce certain complications in the phytoplankton growth, especially phytoplanktons basic growth. The phytoplanktons are undergoes a stunned growth. Their crop yield decreases. Phytoplanktons are destructed in the marine ecosystem continuously. Once there is no phytoplanktons, once there is no producers in the marine ecosystem, means the ecological cycle that is being operated in the marine ecosystem gets upset. So it leads to certain complications in the marine ecosystem. So our harmful UV radiation will affect the growth of phytoplanktons that are present in the marine ecosystem and disturb the ecological cycle, ecological balance. And one more thing, certain ozone depleting chemicals, certain ozone depleting substances are also contributing the greenhouse effect. Greenhouse effect leads to global warming, we know. Due to global warming, the glacier ice that is present in the Arctic and Antarctic region becomes to melt, and hence the sea water level may get risen. Once the sea water level is getting risen, means it will lead to the loss of habitat for these marine animals, especially for these animals. What are all the bad effects of ozone layer depletion on materials? Most of the synthetic polymers are naturally occurring biopolymers. Some other materials of very commercial interest are undergoing destruction by UVB radiation. But nowadays, innovative research is going on to preserve the materials, especially the polymer material, from the UVB radiation by adding some special additives, just like carbon black and titanium oxide, etc. This is due to the exposure. When this rope is exposed to the UVB radiation, it loses its strength. We can see here. What are all the remedial measures? So far we have discussed what is called ozone layer, how it is formed, and what are all the importance of the ozone layer, what is called ozone layer depletion, through which reactions ozone layer depletion happens, what is the specific dangerous condition in Arctic and Antarctic regions, and the effects of ozone layer depletions. All those things we have seen. Now we have to suggest some remedial measures, some control measures we have to suggest. Avoid the consumption of gases which are dangerous to the ozone layer. Some of the most dangerous gases are CFCs, halogens, methyl bromide, and nitrous oxide. Usage of these gases in refrigerators and air conditioning units may be avoided. Instead, we can go for searching some other alternate chemicals. The second one, minimize the usage of cars. The best transport option in urban area is bicycle or walking. When we adopt this, more complications become to an end. Do not use the cleaning products that are harmful to the environment. Ozone depleting substances such as CFCs and the DFCs are mainly present in VOCs, volatile organic compounds especially. in aerosol spray, in blowing agents, etc., these ozone depleting substances are present. Once we are stopping the usage of these substances or these chemicals, we are little bit contributing our society to preserve the ozone layer. So instead of using the solvents, which are very dangerous to the environment, we can use the non-toxic products such as vinegar or bicarbonate. Mostly we people are going for the long distance to get fresh food. That is not favorable one. We have to buy our local products. We can avoid the traveled food because during the traveling, the more nitrous oxide is produced due to the medium used to transport that products. Yes. For transferring process, we are using the vehicles. From the vehicle, nitrous oxides may be released. That nitrous oxides is contributing the ozone layer depletion. So buying the local products, we can preserve our ozone layer a little bit. Air conditioners. Air conditioner is the major source of emitting the CFCs. So we have to maintain our air conditioners in proper manner. Nowadays, instead of CFCs, freon gases, other eco-friendly gases are being used in air conditioners to avoid ozone layer depletion. However, we have to maintain our air conditioners in proper manner because when it malfunctions, more amount of CFCs will be released in the atmosphere. Now let us see the alternative chemicals that are used instead of ozone depleting substances. ODS means ozone depleting substances. Alternate substances, what are they? Fluorinated gases, F gases, have been introduced as the substitute for ODS in many sectors, especially in refrigeration units and air conditioning appliances. These F gases, that means hydrofluorocarbons, HFCs, perfluorocarbons, PFCs, and sulfur hexafluoride, SFCs. So when compared to CFCs, these components, these chemicals are having less dangerous effects. However, even though they are not depleting the ozone layer, but they are the greenhouse gases. This is another problem. These greenhouse gases will lead to global warming. Global warming lead to certain other problems, or other issues. Then the last one is a Montreal Protocol. From the very first slide, we have seen about the Montreal Protocol. In the very first slide, we have seen actually the World Ozone Day, 16th September of 2021 is being celebrated as the International Ozone Day. You know, the main theme of that World Ozone Day is the Montreal Protocol. What is called the Montreal Protocol? The Montreal Protocol is actually the global agreement that is made for all the countries, almost all the countries present in the world, to stop with the production and the consumption of ozone depleting substances. So through this Montreal Protocol, almost all the countries present in the world, they have taken the pledge to stop with the production and the consumption of ozone depleting substances. Actually, this agreement has been made during the year 1987. But the ozone hole development was actually started during the year 1980s, especially in the Antarctic region. Only after 7 years, this agreement has been made, but this agreement has serious influences to stop the ozone layer depletion. It has the very positive approach. How it stopped the ozone hole development in the Antarctic region. Let us see now. And this is the main theme of this Montreal Protocol. Actually, it was signed during the year 1987. We have already seen. This is the ozone hole developments during the year 2018 over the Antarctic region. The diameter of the ozone hole was approximately 7.7 million square miles. But during the next year, 2019, after taking the very positive steps, after preventing the usage of ozone depleting substances, the diameter of the ozone hole has been shrunken to 1.9 million square miles. And this is the ozone hole present over the Antarctic region during the year 2018. Actually, this one. Here we can see how the ozone hole has been shrunken during the year 2019. During the year 2020, 29th December 2020, this picture was actually taken by satellites. Almost the ozone hole has been closed over the Antarctica region. So the Antarctic ozone hole, one of the deepest, largest gap in the ozone layer since the 40 years during from 1980s onwards, has been closed according to the World Meteorological Organization information. This information was given by WMO on January 6th, 2021. This is the evidence. On 29th December 2020, the ozone hole has been almost closed over the Antarctica region. So with this, my presentation is coming to an end. If there are any queries, you can ask now.
So, thank you, sir. Thank you for your wonderful speech. I welcome Dr. P. Saravanan to give a vote of thanks.
Good morning to all. I wholeheartedly thanks to our management, secretary, and principal for giving opportunity to conduct this kind of program. I express my sincere thanks to our resource person, Dr. M.Rukmangathan, Dean Academics, Arasu Engineering College, Kumbakonam. I thank Dr. V. Suresh Kumar, HOD SNH, and Dr. S. Uday Kumar for smooth conduct of this webinar. I thank all faculties and students, those who were attended this webinar. Thank you all.
Sir, thank you so much. Suresh, sir.
Thank you, sir. Thank you.
Thank you, sir.
Thank you.